Okay, so welcome back. So now, we're going to start talking about dividing complex numbers. So, a little different here. When it comes to adding, subtracting, and multiplication, we can do that with complex numbers, but we can't divide a complex number by a complex number directly. Okay, we can't have a complex number in the denominator. Okay, so any fraction of complex numbers we can't work with. So we've got to change the denominator into a real number. So how do we do that? Well, that brings us to what I'm going to talk about right now, which are conjugates. Okay, so conjugates of complex numbers are basically the same. They have the same real part and the same imaginary part. We're just changing the operation from addition to subtraction or subtraction to addition, depending on the case. Okay, so why would we want to use the conjugate? Because that gives us something that we're going to work with, and I'll show you why this comes up. But we want to look at the conjugate pair. So this is a conjugate pair. We've got a plus bi and we've got a minus bi. So this is what we call a conjugate pair. We're multiplying them. Okay? So what happens when I multiply this? Well, I'm going to get a difference of two squares. Why is that important? Well, watch. Okay? So if I use the FOIL method, I get AB plus what? Or excuse me, not AB. This is different. In this case, I get a squared, right? A squared, and then I get what? Minus ABI, and then what do I do when I do the inside? I get plus ABI, and then I do the last, which gives me minus excuse me, not A. BI quantity squared. Okay, so now notice that the middle cancels out. This cancels with this, so we get a squared minus, well, this is a square. Well, let's figure this out. Let's use the distributive property or the power rule for exponents. So I can distribute the power to both of these factors here. So this is going to be the same as b squared times I squared. Well, we already know what I squared is, -1. So that means this changes to a plus. Well, guess what? We get the sum of two squares. Look at that. So with complex numbers, right, when we multiply the conjugates of complex numbers, we get the sum of two squares, and they're both real. That's the key. We get a real number out of this. Okay? So, how does that help us? Well, now we're going to do, now I'm going to show you. Okay. Now let's take this general case. So I'm going to put C plus DI divided by A plus BI. So what I'm going to do is, again, I can't have this complex number down here. So I'm going to get rid of it. Okay? By multiplying the top and the bottom by the conjugate. Why? Because then I'll get a real number in the denominator. So I always want to multiply the top and the bottom by the conjugate of the bottom. So that means I'm going to multiply the top and the bottom by A minus BI. And, oops. Okay, now, what happens? I get that on top, And now, look, what do I get on the bottom? I get this, which just gives me this. So I'm going to get a squared plus b squared on the bottom. So now I just have to FOIL the top and simplify everything. And so in the end, I'm going to get what? I'm going to get AC, what? Plus BCI minus, oh, hold on. Yeah, hold on. Minus BCI plus ADI minus or plus BD. Divided by a squared plus b squared. And so now again, all I did was use the distributive property or the FOIL method. So I get C times A, and then C times negative BI, which gives me this. And then DI times A gives me this. And then DI times negative BI gives me this, because I get I squared, so I get minus BD times I squared, which then gives me plus BD. Okay, so then I simplify this even further, and I get the final answer, which is just going to be AC plus BD plus AD minus BCI over A squared plus B squared. Okay, and that's how you divide complex numbers. Okay, we'll do some examples next time.